Alright, I'm going to just show you some of the basic components going in. You put on a medium-large installation. We're talking about something in the range of 2,000, 4,000 watts continuous. And these are some of the typical components that you might use. The first thing you're going to use when you come off of your solar array, which is going to be, say, a 6 or 8 or 12 panel each of the arrays, is going to be a combiner box. And that is basically that all of the panels on that one array come into the combiner box and are combined, because you're going to hook them up in series or parallel to come up with a certain amount of voltage, and you're not going to want to run 6 or 8 wires all the way down to your, say, batteries or inverter. This combines the panels, and then 2 wires come out of this box. It also has internal fused connectors which go into the box depending on how many panels you have coming in on this array. Then, once you get it down, actually, when you get it down, you're going to come into a charge controller, which is a device like this. This happens to be an Outback Flex 80. Really wonderful, wonderful unit. And I'm going to be doing this on my solar panel instructional at solarpowerdvd.com and solarpaneldvd.com. We're going to tell how to install all this stuff. But basically, your panel feed would come into this baby and then out of this baby to your batteries. But this is completely programmable. It's networkable. It records all the data for the last month or so or more. It's an extremely smart unit, and it's an Mppt controller. That means maximum power point tracking controller, meaning that at any given time it analyzes the voltage and current coming out of the panels, and it will charge any size battery array with a higher voltage array panel, allowing you to run smaller copper into it, but then it intelligently charges any type of 12, 24, 48 volt battery array. All the connections are inside with standard knockouts for use with standard strain relief couplers that you'd use on standard AC wiring. Looking at the inverter, and either you're going to be using a grid tie inverter to just directly hook to your grid, or you're going to be using one that's coming off your battery pack, depending on if you're using an off-grid system or an on-grid system. In your system, you're going to be using large DC breakers, because the power coming out of, say, your battery system going to your inverter is going to be a large breaker like this, 175 amp DC breaker, not inexpensive, not small, but what we electronics people really, call a work of art. This is really nice stuff. So, disconnecting your panels, disconnecting your batteries, all going to go through through DC breakers like this, which are not your standard AC stuff. Okay, so you got to have the right stuff. All right, next, we're going to look in back of it here at the inverter. This is a really nice unit, a Magnesign 3600 watt, also networkable, remote controllable, and this produces better quality power than your power company coming in. It's more stable and more frequency accurate. So basically we'd be coming into this with a lot of DC voltage coming in, all your interconnection points over there you can see coming out. And you'd run this out into a regular AC breaker box and then route it out to your separate AC circuits. So this would feed about 4 15 amp circuits, would be perfectly fine coming out of this baby. And this is one of those ultra heavy duty, ultra heavy and expensive devices. But if you want to produce high quality AC sine wave power, you're going to be using something like this. And any one of the top brands produces this. They've all got beautiful gear. The Magnesign here is the one I happen to be using on this installation. White powder coated, and can produce almost 4,000 watts continuous output with surge capability quite a bit higher than that. So there is, other than your panels, the hardware that you'd be looking at. If this was a grid tie, you'd be looking at a different type of inverter that hooked onto your directly onto your power mains. With the off-grid situation, which I prefer, when the power goes down, you have power. And as well, a lot of times you can get away without electrical inspections because the system is autonomous from the house. It's a freestanding system. I happen to like that, doing things that way.
Hey, time out, Bob.
Mm-hmm.
What if you wanted to do both, say? You wanted to shoot electricity back into the grid and run your house. How would you do that?
Well, it's possible to use a grid tie system with a partial battery backup, and you can have just a little bit of batteries so that you could float your house for a short while, but then have your grid tie installation too. Unless you have federal incentives and state and local incentives, cash incentives to do a grid tie situation, the payout on it is a heck of a lot longer. Your inverters are very high in cost, not as high as it would be to buy a battery bank, but the incentives are going to dictate whether you're going to go with grid tie or not. If you're getting an incentive and write-offs, then you go with grid tie. If you're out in the sticks and you want autonomous power, you're going to go with a battery system. I prefer the battery system. That's what I install at my place because I want to have all of my power when the power goes out, which it does here in Arkansas. So there you go. There's your basic components other than the panels, and it's really just a battery charger.
Well, let's go take a look at the panels.
Okay. Now I'm going to show you a smaller installation here that's in the back that's providing power for my amateur radio station and computers, widescreen TV, and lighting in the basement. It's about a 450 watt system, and it's a battery-based system. So we're going to show you first the battery box. Take a look down here. Classic installation. 3/4 ply, top, and hydraulic lifters because the battery box lid can be heavy. So we've got some triplets. We've got a nice wasp nest. Luckily there's only one. And we'll put our, remember when you're doing lids like this to put a brace bar to hold it up like this. Now in this system here, top left, we're first looking at a Mppt tracking charge controller. This one made by Blue Sky. It's a wonderful device. And it has the power coming in from the panels, coming into it on the bottom and then coming out to the battery. And on the batteries here we're using large crown deep cycle forklift sort of style batteries that are on a bank of 12 volt batteries, 2 in a row. We've got a bug over there. And those are making a bank of 660 amp hours. And when we top those off, I actually have a couple extra Trojans on the side that are taking in the extra power for use in the yard here for weed eaters and things like that on an inverter. When this power comes out, it goes into a 50 amp DC breaker right here, which is the power cutoff to the house. Remember, you've got always have cutoffs and breakers coming in and out of your system. And a lot of these can be rather simple types that are available commonly, but some of the
Now you've got some, what is this, distilled water?
Yeah, oh yeah, you can have your distilled water, of course, to top off.
How often do you top it off?
I would certainly check it every 3 weeks, depending on how much you use your system. So there you go, and in fact this system's still having its cable buried. We'll see down there where the cable's not even finished burying into the ground. So come, let's take a look at the panel array. Well, here we are in part of the garden back here where the solar array is. We do produce 100% of our produce here, our organic produce. In the back you can see the array, and that is the 450 watt array. It is built on pressure treated lumber, and what I had to do was I had to actually get it up and above the trees a little bit, into the trees, because we're so heavily shaded here by large trees in Arkansas. You have to lift the array up. And what I did was go ahead and make it on a cantilevered, I call it my solar power catapult, a cantilevered pressure treated system, and we'll be able to take a little closer look. Of course the angle is straight up for summertime now. But the whole affair tilts over, cantilevers over, so you can work on it. Let's take a look at how that was done. Well, letting this tree grow up in here, I'll clip this stuff out. This entire thing tilts over, and it's counterweighted on the bottom there by cinder blocks, as you can see. So there's 2 cinder blocks counterweighting the array. And all I do, I can take it down as I take off my little rope over here, which just holds the array in position. And then I tilt the whole thing over by just holding these ropes with one hand, and it's perfectly balanced. And the whole affair tilts over until the panels are resting on the back rods over here, these diagonals. Just comes down this way. Now, I mean, I twice a year I change the angle of the panel. That's about it. There's really nothing more. You know, this is pretty much just done. Make sure it's grounded well, and that's it. So there you go. 4x4 womanized. Make a 2x4 frame out of pressure-treated lumber, I'm using the term womanized, and then make an angle bar, you know, through an axle so that you can tilt it like this. Remember that your angle is going to be roughly the average of your latitude. You want to go plus 15 in the winter, minus 15 in the summer degrees, and that will give you your optimum sun hit angle. So I just adjusted according to the seasons. So again, we'll have complete installs on solarpowerdvd.com and solarpaneldvd.com, and they'll tell you how to install this stuff from scratch. Well, you're probably wondering, like, how cost efficient is this? I mean, if I could make money with this and sell it back to the power company, I could retire tomorrow. Well, the reason that isn't the case is because this is extremely expensive to produce solar power. Does it work? Absolutely. I have panels from the Carter administration, 35 years, still on the roof, producing power, just like the day I bought them. But just remember that you're paying, could be 30 cents a kilowatt hour to produce this. Selling it back to the power company at 10 cents a kilowatt hour through a synchronous inverter might not be good economic sense. On the other hand, being independent of the power company is a good idea. And when you put these on your house will sell immediately if you decide to sell it, and at a premium price. So there's hidden values to having solar power plants, and as the electricity goes up, which is going to tremendously from the power companies, this alternative is going to look a heck of a lot more attractive. So the time to act is soon.
Now, Bob, what are the costs of the solar cells? What solar cell do you recommend as a building block?
Well, the values are in the 180 to 200 watt panels right now. They're in short supply, but that's where you're going to get your under $5 a watt value. As you go to smaller sizes, like you would if you bought a bag of apricots or whatever, your value's not as good.
Step us through 1 cell, 2 cells, 4 cells, 16 cells. What do you get for that?
Well, if you're talking 180 watt cells, you're talking 180 watt cell could provide enough power for, say, 6 high efficiency light bulbs, your laptop, run it all day, and run your television big screen for a couple hours at night. 2 cells, double that. You can run, 10 high efficiency light bulbs, a cube refrigerator, and your 2 laptops all day. You could run a little bit of TV at night. 4 cells, 400 watt thing array, you're starting to get a little serious there. You could run a small freezer, a dozen high efficiency bulbs, a tower computer for 4 hours a day, and a laptop all day, and a television for a couple hours at night. So that's basically what you're looking at. If you're looking at really doing the job, you're never going to power the central AC with this. If you wanted to do everything in your house, a 2,000 square foot house with people in it that are efficient users of electricity, you'd be looking at a 12-pack of 180s. That's an installation that this is going in, and that's producing 180 amps continuous charge at 12 volts. 2,200 watts continuous, that's a serious amount of power. That's enough for a cabin, pretty much with everything in it. You want to go to, you don't care how much electricity you use, and you use, you're not efficient, you're talking, 24 panels. If you're talking grid tie, you're talking 24 180s into a $5,000 synchronous inverter. If you have state, federal, and local incentives from your power company to give you rebates. If you, say, live in New York, which in California and New York have the biggest rebates, you could put in a $30,000 system of, 30 panels, 180s, with a synchronous inverter going into the grid, and you would land up paying $6,000 to $7,000 out of pocket once you count all the rebates. So look at your rebates; that'll dictate whether you're going battery or synchronous.
Now talk about the costs. Let's with the cost of the complete cost of a 2-cell, 2-panel system, a 4-panel system, 8-panel, and 16.
So if you're looking
24.
at 6 180s and a battery system and an inverter, which would be like this over here, you're looking at out of pocket, say $7,000. You got a $2,000 rebate credit from the feds till the end of 2008, bringing your cost down to $4,500, $5,000 out of pocket, and that'll give you enough, like I said, for, it'll sell your house quick. You'll power all the stuff in one of the floors of your house.
What about a 24 panel?
Oh, 24 panel, you're powering everything but the central AC in a large house.
What's the cost of that?
Oh, it's depends on your incentives, because there's still federal incentive right now. You may have some local incentives. I'd have to run the numbers, but you're looking at about $1,300 to $1,400 per 180 watt panel when you add the extra stuff. The panels are around $800, and then you're looking at adding $400 worth of inverters, controllers, charging batteries, blah blah blah, to each panel. So multiply it up from there.
Totaling what?
Well, total it up. $1,400 times each panel you buy.
Okay, there you go. All right. Now, so would you say that it would be cost effective, and why would it be cost effective for people to run out and put up one of these systems right now? Why not wait till something better comes along?
It's like waiting for the better digital camera to come out. You're never going to buy one, okay? Because it's cheaper next year, and it's going to be better next year, and you really should just wait till 2057 when then they'll pay you to buy a digital camera. But the truth is, if you can find an item that works now, and you have the money to do it, there are hidden benefits to this. First off, you do not do this because it just makes you money. If solar power made you money, every idiot would do it. No, it doesn't. It's a philosophical commitment to living greener. It's having the bonus of selling your house quick at a premium. It's doing the right thing. This stuff works. If you want to do this, and you're not just doing it to save money, because then there's no philosophy behind it. This is a philosophical commitment as well as a financial. So, I can't give you the numbers and say, you'll make money after 5 years, you can retire and sell extra money to the government, and you can, write a book. No, this is about doing the right thing. And if you have the money, do the right thing.
All right, everybody. We've been talking to Bob Nagy today at Hot Springs, Arkansas. You can get more information at austincast.com and austinlifestyles.com.
Yeah, and
they'll provide links to his
Solar Power
site.
DVD and solarpaneldvd.com
There you go.
for how to do this.
Now you get all the links you need to get started in solar power.
Good luck.
Get your solar car, get your solar house.
And do it quick, because you're not going to be able to buy these soon. When everybody figures this is out, and Joe and Jane Evers do this, you're going to call them and they go, we'll put you on a list, and it's 5 prices on Tuesday, and you're going to wait 2 years. And you'll go, I waited too late. I should have done this last year.